physical world. In this module, we will study about Introduction to the Physical World, Physics, Scope and Excitement of Physics, Physics, Technology and Society, Fundamental Forces in Nature, Nature of Physical Laws, Recapitulation. We all are living in the age of science. Observe all these gifts given by science. What is science? What makes the planets revolve around the sun? Let us find out the answers to all these questions in detail in this chapter.
Before studying about the term physics, we must familiarize with the term science because physics is a basic discipline in the category of natural science, which also includes other disciplines like biology and chemistry. The word science originates from the Latin word scientia, meaning to know.
Science is based on exploration, experimentation and prediction of natural phenomenon. Some of the phenomena in science are occurrence of day and night, occurrence of seasons, formation of eclipses, formation of rainbow, formation of tides, etc.
The word physics comes from the Greek word physis, meaning nature. The Sanskrit word bhautiki is used to refer to the study of the physical world. It is a branch of science which devoted to the study of nature and natural phenomena. In the study of physics, the two principal thrusts are unification and reductionism. Let us study about them one by one. Unification refers to the attempts made to explain diverse physical phenomena in terms of few concepts and laws. For example, some law of gravitation is behind the fall of an apple to the ground, motion of the planets around the sun, and motion of the moon around the earth. Reductionism means attempting to derive the properties of a bigger, more complex system from the properties of its constituent simpler parts. For example, the subject of thermodynamics deals with the study of bulk systems in terms of macroscopic quantities such as temperature, entropy, internal energy, etc. Similarly, the subjects like statistical mechanics and kinetic theory interpreted temperature, entropy, internal energy in terms of properties of the molecular constituents of the bulk system. To know about the scope and excitement of physics, let us take a look at its various subdisciplines. Macroscopic domain includes the study of phenomena involving objects of finite size on terrestrial scale and even on astronomical scale. Classical physics includes the branches of physics like mechanics, thermodynamics, electrodynamics, optics. The given phenomena are dealt in the branch of classical physics known as mechanics. Thermodynamics is the study of gaseous systems. It deals with the systems in macroscopic equilibrium and is concerned with the changes in temperature, internal energy, and entropy of the system. It also includes modes of transfer of heat, efficiency of heat engines and refrigerators. Electrodynamics deals with the study of electric and magnetic phenomena associated with charged and magnetic particles. The basic laws governing this phenomena were given by Coulomb, Oersted, Ampere, and Faraday. Electrodynamics can explain about the motion of a current-carrying conductor in a magnetic field, the response of a circuit to an alternating voltage, the working of an antenna, the propagation of radio waves in the ionosphere. Optics involves the study of various phenomena connected with light and optical instruments like microscope, telescope, etc. Let us try to analyze our knowledge gained from the module covered till now. The propagation of radio waves in the ionosphere is dealt in A. Electrodynamics, B. Optics, C. Thermodynamics, D. Mechanics. The answer is option A. Electrodynamics is the branch of physics that deals with electromagnetism or with electric and magnetic phenomena associated with charged and magnetic bodies. Radio waves are electromagnetic waves. So the propagation of radio waves in the ionosphere is dealt in electrodynamics.
Microscopic domain involves the study of phenomena linked with atoms, nuclei, and other elementary particles. Modern physics comprises this domain.
As we all know, the scope of physics is very wide. It covers a tremendous range of magnitude of physical quantities like mass, time, length, energy, etc. It can deal with phenomena of the small scale of length of the order of 10 raised to the power minus 14 and also of large scale of length, that is, of the order of 10 raised to the power 26. In physics, on one hand, we have phenomena of time scale 10 raised to the power minus 22 seconds, while on the other hand, we have phenomena of time scale 10 raised to the power 18 seconds. Also, the range of masses in physics varies from mass of an electron 10 raised to the power minus 30 kg to mass of known observable universe 10 raised to the power 55 kg. Do you know the reason behind the phenomenal progress of physics in the last few centuries? It is due to the following reasons. 1. Basic laws of physics are universal. 2. The strategy of approximation was very successful. Let us understand it through an example. A brick and a feather dropped from the same height do not reach the ground at the same time due to the air resistance. Therefore, the phenomenon, namely free fall under gravity, is complicated by the presence of air resistance. Thus, to get the law of free fall under gravity, it is better to generate a situation where the air resistance is negligible. When the same brick and feather are dropped in a long evacuated vacuum tube, they both fall almost at the same rate, giving the notion that the acceleration due to gravity does not depend on the mass of an object.
The study of structure of atoms, radioactivity, X-ray diffraction, etc. in physics have enabled chemists to rearrange different elements on the basis of atomic number in a periodic table. This gives better understanding of a chemical bonding and complex structures. An optical microscope is an important instrument developed in physics, are extensively used in the study of biological samples. The astronomical telescopes developed in physics are used by astronomers for observing planets and other heavenly bodies in the sky. Physics have developed many mathematical concepts. The other subjects like geology, meteorology, biophysics, etc. also use some of the laws of physics. The invention of fax machines, telephone, mobiles, etc. enables us to transmit messages and information in very short interval of time. The development of television, radio, satellites, etc. increases the means of communication. Advancement in electronics, computers, and lasers have greatly enriched our society. Invention of steam engine in 18th century played a key role in the Industrial Revolution in England. It was developed on the law of thermodynamics. Launching of satellites has enabled us to predict the weather conditions and improve the communication facilities. Development of Carnot cycle has enabled us to realize refrigerator, AC, etc. Technology of wireless communication is based on the fundamental laws of electricity and magnetism.
Let us now take a look at some physicists with their major discovery and country of origin. From this table, we appreciate the multicultural international character of the scientific endeavor. Technology and physics are closely related. All technologies are based on the principles of physics.
All these activities need force.
Sir Isaac Newton gave the correct notion of force in his statement of the laws of motion.
In macroscopic world, besides the gravitational force, we come across several other kinds of forces such as muscular force, frictional force, surface tension, viscous force, etc.
In microscopic world, several kinds of forces are electric and magnetic forces, nuclear forces involving protons and neutrons, interatomic and intermolecular forces. Let us know about the four fundamental forces of nature with the help of an animation.
Forces in nature. The Earth and other planets revolve around the Sun. Can you think what holds the Earth when it revolves around the Sun? The electron has negative charge, whereas nucleus has positive charge. Then electron should have been attracted by the nucleus, but we can see that it revolves around the nucleus instead of getting attracted towards the nucleus. Can you think what makes the electron to revolve around the nucleus? Nucleus is composed of chargeless neutrons and positive charged protons. Even there is a force of repulsion between the protons due to the same charge on them, but still nucleus do not breaks. Can you think why? Can you think how? The neutrons gets converted into protons, electrons and antineutrino. In each case, there exists a force. Can you tell which type of force acts? Gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. All these are fundamental forces of nature. Let us study the nature of each of the forces one by one. Gravitational force is one of the four fundamental interactions of nature. It is due to the gravitational force which keeps the Earth and other planets in their orbits around the Sun. It is due to the same force which keeps the Moon orbiting around the Earth. There is a popular story that Newton was sitting under an apple tree. An apple fell on his head. The apple fell down due to the gravitational force between the Earth and the apple. From this, the idea of formulating the law of gravitation came into the mind of Sir Isaac Newton. Gravitational force is a weak force and applicable to long range. Electromagnetic force exists between charged particles. An atom consists of nucleus and an electron revolves around it. An attractive force should exist between the electron and proton. But inside the nucleus, repulsive force exists between protons, which in turn prevent the electron to get attracted. Because of this electromagnetic force, the atomic structure is stable. The electromagnetic force holds these electrons in their orbit around the nucleus. Let us understand more clearly by taking an example from daily life. Let us consider a heavy block hanging from the ceiling by a string. We can see that string is composed of electrons and protons. And similarly, block is also composed of protons and electrons. Do you know the reason why block attached to the string does not fall down? The electrons and protons at the lower end of the string exert force on the electrons and protons of the block. Thus, a resultant force is exerted by the string on the block. The block does not fall because of the electromagnetic force attracting between the block and the string. Let us study about strong nuclear force. Here we can see protons and neutrons inside the nucleus. There exists a force of attraction between proton and neutron. even though neutrons do not have any charge, but then also they are attracted by the protons inside the nucleus. Do you know how? This is due to strong nuclear force which exists between them. This force is charge independent. This force is short-range force. This force is 10 times stronger than repulsive electric force. That is why it is able to hold the nucleus despite of the repulsion between the protons. Strong nuclear force comes into play in nuclear fusion and nuclear fission reactions. Hydrogen bomb is an example of strong nuclear force. It is based on the process of nuclear fission. There is another force called the weak nuclear force. Such forces exist inside the nucleus between elementary particles. Weak nuclear force can be seen in the process of beta decay. In beta decay, a neutron gets converted into a proton. During this, an electron and an antineutrino are emitted. If such force would not have existed, then much radioactive matter would have been stable.
Let us go through the table showing us the details of progress in unification of different forces or domains in nature. Some special quantities remain constant in time. They are the conserved quantities of nature. Let us understand the conservation principles, which are very important to explain the observed phenomena more quantitatively. The important conservation laws of classical physics are mentioned on the screen. According to law of conservation of energy, energy can be transformed from one form to the other or transported from one place to the other, but the total amount of energy never changes. This law is applied in the analysis of atomic, nuclear, and elementary particle processes and is valid for all forces and for any kind of transformation. let us understand it with the help of an example. As we drop a ball from a certain height, then though its kinetic energy increases with decreasing height, but the sum of kinetic and potential energies of the body remains constant at all time. In an electric fan, electricity is converted into mechanical energy. In a windmill, the mechanical energy of the wind is converted into electricity. According to the law of conservation of angular momentum, if the total external torque acting on a system is zero, then the angular momentum of the system remains constant. This law of conservation of angular momentum can be observed in the orbital motion of the planets around the Sun. According to the law of conservation of linear momentum, in the absence of an external force, the linear momentum of a system remains conserved or unchanged. Only an external force can change the linear momentum of the system. The internal forces come in balanced pairs that cancel within the object. Connection of conservation laws with symmetries. All the conservation laws have a deep connection with symmetries of nature. These laws of nature do not change with time. The laws of nature are same everywhere in the universe. However, the phenomena may differ from place to place because of different conditions at different locations. The symmetry of the laws of nature with respect to translation in space give rise to law of conservation of linear momentum. Similarly, isotropy of space underlines the law of conservation of angular momentum. The conservation of charge and other attributes of elementary particles can also be related to certain abstract symmetries. Therefore, symmetries of space and time and other abstract symmetries play a key role in modern theories of fundamental forces in nature. Science theory, mass m is equivalent to energy E given by the relation E is equal to mc square, where c is the speed of light in vacuum. According to the Einstein relation, energy can be obtained at the cost of mass and vice versa. Consequently, the law of conservation of mass was included in the law of conservation of energy. There are two types of chemical reactions. 1. Exothermic reaction. 2. Endothermic reaction. In exothermic reaction, the total binding of the reacting molecules is less than the total binding energy of the product molecules. In endothermic reaction, the total binding of the reacting molecules is more than the total binding energy of the product molecules. By now we have covered all the important concepts related to the chapter Physical World. Let us take a recap. We had learnt about macroscopic and microscopic domains. We had also studied the interrelationships between physics and other branches of science and technologies. We also learnt about the four fundamental forces of nature and their important properties. We also studied some important conservation laws. Let us take a look at some of the important terminologies. Let us go through a small insight related to the